Hello, you are welcome to Tutor Think. In this video, I am taking the second and final example of finding the root of a quadratic equation. And in the first video, I did a few explanation about the discriminant of a quadratic equation of a polynomial function per se, and it will help you to understand how to know if a quadratic equation given to you will generate real or what complex roots or repeated factors or repeated roots. So you need to watch that, because in this one I am not going to talk about the discriminant. I'll just move straight forward. So you can see the first example of this video on my playlist, Engineering Maths 2 Quadratic Equations. So we have been given the equation x squared minus 2x plus 17 equal to 0. And all we need to do is to generate the root of this equation. And note that this is a complex root. It will give us a complex root. You need to watch my first video to understand how to know if it will give you a complex root. So I will use the quadratic formula, but before I do that, let's name this equation 1, and let's compare equation 1 with ax squared plus bx plus c equal to 0. And let's name this equation 2. So we know that a, when we compare a here, the coefficient of x squared here is 1, so a equal to 1, and b equal to minus 2, which we have here, and c equal to 17. So we can just apply the quadratic formula. So we have from minus b plus or minus root of b squared minus 4 AC all out of 2a. Let x be equal to this so that we can generate x1 and then x2. So we substitute the values of a, b, and c to complete the calculation. B is minus 2, so we have minus into bracket minus 2 plus or minus root of minus 2 square minus 4. A is 1 and c is 17 all out of 2. A is 1. We can expand this. We have x being equal to negative times this is giving us 2 plus or minus root of this is giving us 4 minus 4 times 17 is giving us 68. This is what we have, all divided by 2. So we have x being equal to 2 plus or minus root of, so now when we subtract this we are left with 64, so all out of 2. So now we can say that x is giving us 2 plus or minus root of 64 times root of negative 1. So you must know that this time this is the same as this, and root of negative 1, I'm just using this method to explain. You can jump this step straight forward, there's no need. Root of negative 1 will give us I. So root of negative 1 is equal to I. If this is your first time watching this, go over the channel, my channel, open Introduction to Complex Numbers to go over the explanation for this under Engineering Maths 2. So we can now say that x will be equal to 2 plus or minus root of 64i all over 2. And you can punch root of 64 on your calculator. The result is 8. So we have 2 plus or minus 8i all over 2. So finally, x equals 2 out of 2 plus or minus 8i over 2. So we can break this down. 2 into this will give us 1. We have 1 here, and we have 4. So we have our x equals 1 plus or minus 4i. So we have x1 giving us 1 plus 4i, and the second one, x2, giving us 1 minus what? 4i. So this is it. These are the complex roots that we generated. One is real, one is imaginary, one is real, one is imaginary, and then one is positive, one is negative. So I am going to test you with one, just a simple one. You solve it yourself. I'll give you the possible answers to cross check if you are right. And so you will solve this one for me. This is for you. The root of the equation will be x equal to -1 out of 2 plus or minus I over 2. This will be the same as x1 giving us 1 out of 2 plus 1 out of 2I, and x2 giving you 1 out of 2 minus 1 out of 2I. So this will be your final answer. So you use the same process I went through to generate these roots, and if you are able to do that, then clap for yourself. Congratulations. So I'll see you in the next video. In the next video, I'll be talking about how to form the quadratic equation when the roots are given to you. So that is what I'll be doing in the next video. You can stay tuned for that.